All right, so hopefully you had a chance to do the your turn questions. So let's take a look at the first one. It says a motorboat traveling 5 meters per second east encounters a current traveling 2.5 meters per second north. So for part A, we'll do our work over here and we'll say, okay, so it's going 5 meters per second. That is 5 meters per second east, and that is the velocity of the boat with respect to the water. And now the water is moving this way at 2.5 meters per second north. And so my resultant can be looking like that. And it says, what is the resultant? Here it is. What's the resultant for those two? So the answer would be, it's just some straight Pythagorean work here. We got an r, we got a theta. So r is going to be equal to the square root of 5 squared plus 2.5 squared. And the answer for that, I think, will end up being about 5.6 meters per second. And my theta here is going to be the inverse tan of 2.5 over 5, which is approximately 27 degrees. So my answer for A would be 5.6 meters per second at 27 degrees. So that's how the boat would be moving with respect to the ground, or if someone was watching from the shoreline. Part B asks, now, if the width of the river is 80 meters wide. So this here was a velocity vector. And so now we are talking about a displacement. And so in our displacement here, the boat will be traveling a horizontal or east-west displacement of 80 meters. And these two triangles are going to be similar. So this angle, it will be the same as this angle here. And so what we can do is we can find the time using two going in the same direction. So my basic formula is velocity for constant velocity or average velocity. V is equal to delta D over delta T. If I want to solve for time, I'll get time is equal to delta D divided by V. So my time is going to be equal to 80 meters divided by 5 meters per second, which is 16 seconds. So there is my answer. There's my answer for B. The last question is part C. I think I'll switch to red for this last one. For part C is, what distance downstream does the boat reach the opposite shore? In other words, what is this here? We'll put an X there. What is X? Equals question mark. Okay, well, if it takes 16 seconds to get across, it's going to be moving in this distance 16 seconds as well. So what I will do is I'll say, okay, this is the velocity with which it's going north. So how far it goes north would be that x over there. So I'm going to say delta D is equal to V times delta T. Again, it's just another variation solving for delta D on that equation, and I'm going 2.5 meters per second for 16 seconds. So 2.5 times 16 is 40 meters. So there we go. So even though he's going, or he or she, the boat, is going in this direction, during that period of time that it takes to get across, and it moves the 80 meters horizontally, it takes 16 seconds. During that 16 seconds, it moves 40 meters downstream. D says, if the current were increased to 5 meters per second, then how much time would it take to cross the same river? So what they're doing is they're saying, if we change this 2.5 to a 5, okay, so then my original diagram would look like this. I would still have the 5 here, meters per second, but this would change to a 5 meters per second. And in my displacement diagram, this would still be 80 meters. Okay, and that would be, well, actually it's pretty clear to tell that's going to be 80 meters as well. So how much time would it take to get across? It's still going to be exactly the same, because how fast they're moving eastward is still 5 meters per second. The current doesn't change that, and they still have to go 80 meters. So it's still going to be 16 seconds, exactly the same. What distance downstream does the boat reach to take the opposite shore? Well, I was just looking at this in terms of similar triangles. If this is a 5 and a 5, that has to be an 80 and an 80. So I'll say 80 meters. But if you're not convinced, you could look at the method we had before. Here we said, well, if it was going 2.5 meters per second for 16 seconds, now it'll be going this 5 meters per second for 16 seconds. So it would be very similar, and we would say this delta D is going to be equal to the velocity with which it's going east multiplied by the time. So it would be 5 meters per second times 16, which would also be 80 meters. Okay, there is your answer. So enjoy. This is an assignment here to work on the 5th sheet of the package, and you can be working on the sublevel 6, and I will be handing you a review if you don't already have it when you hear this video. Thanks.